Hey kids, it's me again. So this is the second part of week 4 lecture video. Alright? Pwede pang humabol. You may key in your answers in the comment section below for the question for the day. Okay, so annuity due is the second type of annuity certain that we are going to discuss. So what is an annuity due? Well, it is a series of payments made at the beginning of each period. So if you recall our annuity immediate, payments there are made at the end of each period. So yun yung main difference ng annuity immediate and annuity due. So again, let's have a timeline. So the timeline looks like this. If we consider payments of 1 unit or 1 peso at the beginning of each year for n years. So same as the annuity immediate. Okay, so that's our timeline. So you can see the first payment is made at time 0 because this is the beginning of the first year. All right, this one at t equals 1, this is the beginning of the second year. Well, the last 1 unit here, this is the payment at the beginning of the nth year. So later, we're going to recall the timeline for an annuity immediate. For now, let us focus on this timeline. Okay? So we get the present value and the accumulated value of an annuity due. So present value, we take t equals 0 as our valuation date. Right? So we carry everything to times 0. So again, this is the process of discounting. So the first term is 1, and then plus 1 times v. That's how you carry 1 to times 0, and so on. And then the last term will be 1 times v to the n minus 1. All right? So we have this. And again, this one is a geometric series. So we use the geometric formula. Geometric series formula. That's why we have this one. Okay? So this is the first term times 1 minus r. Okay? Raised to the number of terms all over 1 minus r. All right? We can still simplify this. And it becomes 1 minus v to the n all over d. Diba? 1 minus v from the relationships among different measures of interest. 1 minus v is equal to d. Right? And we have a new actuarial symbol here, which is a double dot angle n. So what is this one? This gives the present value of a series of payments of 1 unit made at the beginning of each year for n years. Okay? Of course, using I as the effective rate of interest. Okay? Per year. And don't forget your D here. How do you write D in terms of I? All right. D is equal to I over 1 plus I. Okay? Please don't forget that identity. Okay? Now we get the accumulated value of an annuity due. Okay? Let's have this timeline again. Payments of 1 unit at the beginning of each year for n years. This is how we get the accumulated value. So at t equals n, we carry everything to this point. Okay? So maybe we can start here. Okay? Here. We can carry this to time n if we multiply 1 by 1 plus I. Okay? Here. Okay? And then this one, how do we carry this to time n? We multiply it by 1 plus I raised to n. And we have this. So we have this, diba? Okay? And if you inspect closely, this again forms a geometric series. Okay? With common ratio equal to 1 plus I. Okay? And then applying the geometric series formula, we're going to have this. Again, this is the first term, A1, times 1 minus R raised to the number of terms all over 1 minus R. Okay? And then simplifying, we're going to have this. What happened? I put this 1 plus I here in the denominator. Okay? And then 1 minus 1 will cancel. And then I'll have a negative I. But I will put the negative in the numerator. So that's the reason bakit nag-switch ang 1 plus I raised to n at saka yung 1. Alright? Okay. And here, saan equal ang I over 1 plus I? It is equal to D. That one. And this is what we call our S double dot angle N. This is the actuarial symbol for the accumulated value of a series of payments of 1 unit made at the beginning of each year for n years. Okay. To compare annuity immediate and annuity due, let's have this table. Okay? So, annuity immediate payments are made at the end of each period. Annuity due payments are made at the beginning of each period. And then you compare the formulas in getting their present values, and of course the formulas in getting their accumulated values. Medyo magkamukha, no? Okay? What is the only difference? Their denominators, right? Kasi sa present value, pareho ang numerator, 1 minus v to the n. 1 minus v to the n, right? Pati dito sa accumulated value, same numerator, 1 plus I raised to n minus 1, dito din. For the annuity due, 1 plus I raised to n minus 1. Diba? So, madali lang itong i-memorize because kapag annuity immediate, ang nasa denominator is a letter I. Ayan immediate letter I. So, I ang nasa ilalim. And then if it's due, letter D naman ang nasa ilalim. See? So, you can easily memorize these formulas. Now, para hindi rin kayo mahirapan mag-memorize kung sino ba yung end of the period or end of every period, sino yung beginning of every period, ganito lang yon. Annuity immediate. Immediate starts with a vowel. It's a vowel I. Ang kapartner niya, si end. At the end of each period. End, starts with a vowel E, right? And then here for an annuity Jew starts with a consonant D. Okay, and if you recall, payments are made at the beginning of each period. So ang kapartner ni annuity Jew ay beginning. And beginning starts with a consonant B. See? So para siyang vowel, vowel, consonant, consonant. Okay? More relationships on these two annuities. Okay. So we now relate their present values. Okay, like A angle N, this is the present value for an annuity immediate. A double dot angle N, this is the present value of an annuity due. Okay, of course you can easily prove this algebraically. Okay, pero si teacher, I use timelines to establish these identities. If you don't like to memorize identities, kasi ang dami na from the measures of interest pa lang, di ba? You have so many identities to memorize. But if you want to lessen memorization, you may want to consider timelines. And then all the identities will follow. Identities showing relationships between annuity immediate and annuity due. Okay? Okay, let us have timelines here. That one. This is the standard timeline for an annuity immediate, right? Yeah. Payments are made at the end of each period, yeah, for n periods. Okay. Now, I'm going to have this second timeline. Let's consider this black timeline as our original timeline. Okay? So, do you recall, ginawa natin ito sa part 1 of week 4 lecture video. Okay? So, ganito yan. Let's say I want to get the present value of all these black ones here. So, if I want to get the present value of all these black ones here, so the value is equal to this point, so the value is equal to A angle N, right? It's A angle N at time 0. Now, let's consider the red timeline. Okay? Let's consider first that this is our time 0. Okay? And you want to get the value of all these red ones at time 0. So what is the value? That will be A double dot angle N. Why A double dot? Because you see, payments are made at the beginning of each period for N periods, right? So that's why if you carry all the red ones here at time 0, yan, red 0 here, the present value is A double dot angle N. So you have a single value here kasi na-carry mo na lahat to time 0. So this A double dot angle N at this point is at time 1 pa lang doon sa original black timeline. Okay? So yung A double dot dito, kapag nilagay ko siya sa black timeline, yung A double dot angle N is still at T equals 1. We need to carry it to time 0. So how are we going to do that? How do we carry a value at time 1 to time 0? So you just multiply it by V. So that's why we have this. A double dot angle N times V. And that is equal to A angle N. Okay? You can do the same for S and S double dot. Okay? Paano yon? Where is S angle N? S angle N, this is the accumulated value at T equals N. So, ibig sabihin, the value of all the black ones here at T equals N. Okay? Nasa T equals N ang valuation date. You carry all the black ones to T equals N. Alright? Okay. Now, we consider this red timeline. Okay? So, it should be clear that this is the timeline for an annuity due. Okay? If you evaluate the accumulated value for this red timeline, so the valuation date will be at this point. Right? So, you carry everything to time N. And you're going to have S double dot angle N. Okay? S double dot angle N. But, when you put this here sa ating black timeline, parang may extra one period, di ba? Kasi parang ito siya, oh. Ayan. There's an extra period here. You have to carry the S double dot angle N back to time N. Kasi that is our original valuation date. And how are you going to carry an amount here back to time N? You multiply it by V. So that's why we have like this. Okay? Okay, so I hope you understand how do I prove these identities using timelines, because we have more identities here relating the annuity immediate and the annuity due. Okay? Madali lang naman ito. So, yung pinrove natin kanina, that's number 3 and number 4. Okay? Again, algebraically, madali lang ito. Okay? You have to memorize if you don't like to make use of timelines. How to use timelines in establishing all the identities here. Let's have number 1. It says A angle N is equal to V to the N times S angle N. Alright? So, tingnan nyo to. So, this is for an annuity immediate. Okay, where is A angle N? A angle N is evaluated at time 0. Right? Where is S angle N? To. S angle N is evaluated at T equals N. Okay. Let's consider the S angle N. So, what is S angle N? You carry all to time N. Okay? That is the accumulated value of all the payments that you see here. Okay? So, S angle N is a single amount at time N. That's a single amount at time N. You want to carry it to time 0 para kunin yung present value niya. So, a single amount of money, you want to get its present value, so you have to carry it to time 0. And how are you going to do that? How do you carry an amount here to time 0? So, all you have to do is to multiply it by V to the N. That's why I have this. Your S angle N multiplied by V to the N is the present value of the payments of one unit at the end of each period for N periods. Okay? Siyempre, ganun lang din dito. Okay? Your A angle N, where's your A angle N? At time 0. That's your A angle N. A single amount of money at time 0. Kasi na-carry mo na value mo na lahat ng 1 na ito to time 0. So, you have a single amount here. You want to carry it to time N. How are you going to do that? How are you going to carry a single amount here at time 0 to time N? So, all you have to do is to multiply your A angle N here by 1 plus I raised to N. And this is what we have. right? That is equal to the accumulated value of an annuity emitted. Okay? Of course, other identities here follow. Okay? All you have to do is to understand the use of timelines. All right?